Welcome to Fat Math. In this video, we will have solving logarithmic inequalities. So we will use the properties of the logarithmic function here, that if the base is between 0 and 1, that is greater than 0 and less than 1, then the function is a decreasing function. That means to say that x is less than y if and only if the logarithm of x to the base b is greater than the logarithm of y to the base b. So how are we going to use this property? That means to say that if we have logarithm of x to the base b greater than logarithm of y to the base b, then we will have x is less than y. Meaning to say what's in here should be less than what's in here. And then if the base is 0, then the logarithm of x to the base b is less than the logarithm of y to the base b. We will have x less than y, meaning to say what's in the logarithm here is also less than what is in here. Okay, let us have an example of that so that you can understand better. Number 1. Logarithm of 2x minus 6 to the base 5 is greater than or equal to the logarithm of x plus 2 to the base 5. So using the property, our base here is greater than 0. So if the logarithm of 2x minus 6 is greater than or equal to the logarithm of x plus 2, then 2x minus 6 is greater than x plus 2. That is because the base is greater than 0. And then we will solve this one. This is a linear inequality. Put x to the left, that will be negative x. And then put negative 6 to the right, that will be positive 6. So we will have 2 plus 6 on the right. 2x minus x is x. And 2 plus 6 is 8. So x is greater than or equal to 8. But in this case, in this logarithmic inequalities, we should not conclude immediately that the answer is all numbers greater than or equal to 8. We have to look at the part here inside the logarithm. The 2x minus 6 for the logarithm to be defined should be greater than 0. Likewise with x plus 2. So x plus 2 and 2x minus 6 should both be greater than 0. So 2x minus 6 is greater than 0 if 2x is greater than 6, and that is if x is greater than 3. X plus 2 is greater than 0 if x is greater than negative 2. And here we have 3 solutions, so we have to identify the intersection of these number lines or these solutions. Okay, for 8, 3, and negative 2, we have to arrange them in the number line. We have to locate them in the number line. Of course, we have to put the lowest or the least to the leftmost, and then the biggest to the right. So the lowest is negative 2, followed by 3, and then the biggest of the 3 of them is 8. So 8 should be on the right. Okay, let's have x is greater than or equal to 8. That is all numbers greater than or equal to 8. So from 8, we have here an arrow from 8 going to positive infinity. We're using here a solid circle because we have here greater than or equal to 8. So 8 is part of the solution. For the second one here, x is greater than 3. So we have this arrow. So all numbers greater than 3 are in this green part here. Second arrow. But as what you can see here, the circle is a hollow circle. That means to say 3 is not part of the solution because we have here x is strictly greater than 3. And then for x greater than negative 2, that's also all numbers to the right of negative 2. So if we will look at the 3 arrows here, what's common to them is this part here. So all numbers here in this interval. Not this one here, not this one here, not also here, but only the ones here, common to the three of them. So all numbers greater than or equal to 8. So we have to identify the intersection of these three intervals. So we can conclude now that the answer or the solution is the set of all real numbers greater than or equal to 8. In interval notation, that is bracket 8, positive infinity. Let us have a second example. Logarithm of 3x plus 3 to the base 3 is greater than or equal to logarithm of x minus 3 to the base 3. So same. If the logarithm is greater than the other one, then what's inside should also be greater than what's inside the other one. That is because the base is greater than 1. So 3x plus 3 should be greater than or equal to x minus 3. Solve this linear inequality. Transfer x to the left and positive 3 to the right. We will have 3x minus x is greater than, copy negative 3, and then you put 3 to the right, that will be negative 3. 3x minus x is 2x, negative 3 minus 3 is negative 6. Divide both sides by 2, you will get x is greater than negative 3. And then, what's inside the logarithm should be greater than 0. So, this one here and this one should be greater than 0. So, 3x plus 3 is greater than 0. Transfer 3 to the right side. You will have 3x is greater than negative 3. Divide both sides by positive 3. You will get x is greater than negative 1. And then, x minus 3 should also be greater than 0. So, put negative 3 to the right. You will have x is greater than 3. So we have three numbers here, negative 3, negative 1, and 3. And we have to arrange them on the number line. So the lowest is negative 3. The next one is negative 1. And the biggest of the three of them is positive 3. So x is greater than or equal to negative 3. We will have that one, all numbers from negative 3 and going to the right, because greater. And then for x greater than negative 1, we have that one hollow circle at negative 1 because negative 1 is not part of the solution. And then x greater than 3 is this part here. So what's common to them is still this part here. Common to the three of them. So that is all numbers greater than 3. So all real numbers greater than 3 can satisfy the given inequality. In interval notation, that is, you have 3 parenthesis 3 positive infinity. Another example. Example number 3. Solve logarithm of 3x minus 1 to the base 4 is less than or equal to the logarithm of x plus 5 to the base 4. So here the base is 4, which is greater than 1. So we will have 3x minus 1 is less than or equal to x plus 5. So what you can observe, if the base is greater than 1, if it's less than, still less than if you get the logarithm. Same with if it's greater than. If it's greater than, still greater than. Because of the property of the logarithmic function, that if the base is greater than 1, then the logarithmic function is increasing. So put x to the left, put negative 1 to the right. We will have 3x minus x is less than or equal to 5 plus 1. 3x minus x is 2x. Less than or equal to 5 plus 1 is 6. Divide both sides by 2. You will get x is less than or equal to 6 divided by 2 is 3. So x is less than or equal to 3. And of course, don't forget that 3x minus 1 should be greater than 0 and also x plus 5. 3x minus 1 is greater than 0 if 3x is greater than 1. Divide both sides by 3. You will have x is greater than 1/3. X plus 5 is greater than 0 if x is greater than negative 5. Locate these three numbers on the number line. The lowest or the least of them is negative 5, followed by 1/3 and then 3. X less than or equal to 3 is this one. from 3 going to the left. X greater than 1/3 is that one going to the right because it's greater. And then x greater than -5 is also going to the right. As what you can see here, hollow at -5, hollow circle at 1/3, and solid circle at 3, because at 3, we have here less than or equal, meaning to say 3 is part of the solution. So, what is common to the 3 of them? Is it this part here? No, because the other 2 don't have a part here. Is it this part here? Not also, because there are only 2 of them here. Is it here? Yes, but not this part here, because there are only 2 rays or 2 intervals that have parts here. So what's common to them is this part here. All numbers greater than 1/3 but less than or equal to 3. So we write that in interval notation as that parenthesis 1/3 and then 3, and then we put a close bracket there. That means to say 1/3 is not part of the solution while 3 is part of the solution. So you can have that, you can read that as the set of all real numbers greater than 1/3 but less than or equal to 3. Let us have another example. Actually, you can already have this as your practice exercise. You can answer this on your own and then pause the video, and then you can check your answer after. Here, same, the base is greater than 0. So if the logarithm of 4 minus x is greater than the logarithm of x plus 8, then 4 minus x should be greater than x plus 8. And then, this is a linear inequality. Put x to the left, we will have negative x. Copy that. We will also put 4 to the right. So put x to the left, you will have negative x. Copy greater than, copy 8. And positive 4, if you put to the right, that will be negative 4. Negative x minus x is negative 2x. Copy greater than. 8 minus 4 is 4. And then divide both sides by negative 2. If we multiply or divide both sides of an inequality by a negative number, we should reverse the inequality symbol. That is the multiplication property of inequality. If you're dividing by a positive number, if it's you don't change the inequality symbol. But if you multiply or divide by a negative number, you have to reverse the inequality symbol. That is the multiplication property of inequality. So if you divide both sides by negative 2, negative 2x divided by negative 2, that is x. And then it will be less than, because we divided by a negative number. 4 divided by negative 2 is negative 2. Don't forget that 4 minus x should be greater than 0. So put 4 to the right, you will have negative x is greater than negative 4. How do we solve that? Divide both sides by negative 1 so that negative x will be positive x. And then since you are dividing by negative 1, you have to reverse the inequality symbol. So instead of greater, it will be less. And then negative 4 divided by negative 1 is positive 4. And then x plus 8 should also be greater than 0. That is when x is greater than negative 8. So identify or locate on the number line the numbers negative 2, 4, and 8. Of course, the least is negative 8. Next to that is negative 2. And then the biggest of the 3 of them is positive 4. So x less than negative 2, since that is less than, we start from negative 2, not including negative 2. And we move to the left. And then x less than 4, we start from 4, but not including 4, so hollow circle on 4, but we have to move to the left. And then x greater than negative 8, we start from negative 8, and we move to the right, because it's greater than. So what is common to the 3 of them? Which part? Is it here? No. Is it here? Yes. So here, because the 3 of them are here. 3 of them have parts here, so the answer is only here. No, not anymore this one here, because the lower or the lowest arrow here does not have a part here anymore. Also here. Okay, so the answer here is the set of all real numbers greater than -8 but less than -2. So all numbers in that interval can satisfy the given logarithmic inequality. Example number 5, logarithm of 9 minus 2x to the base 1/2 is greater than logarithm of 2x plus 1 to the base 1/2. As what you can see here, our base is less than 1. So if it's less than 1, if it's greater, if you get the logarithm, then you should interchange. You should, reverse the inequality symbol. So instead of greater than, you will have 9 minus 2x is less than 2x plus 1. Put 2x to the left, put 9 to the right, you will have negative 2x minus 2x is less than 1 minus 9. Negative 2x minus 2x is negative 4x. Less than 1 minus 9 is negative 8. And then divide both sides by negative 4. So if we are dividing by a negative number, we should also reverse the inequality symbol. Negative 4x divided by negative 4 is x, and then it should be greater than. Negative 8 divided by negative 4 is positive 2. So x is greater than 2. But don't conclude yet that that is already the final answer, because 9 minus 2x should be greater than 0 and the 2x plus 1. So 9 minus 2x is greater than 0. Put 9 to the right. That will be negative 2x is greater than negative 9. Divide both sides by negative 2. You will have x is less than 9/2. As what you can see here, we divided by negative 2. So the greater than symbol will be less than. And then 2x plus 1 should be greater than 0. So 2x is greater than negative 1. Divide both sides by positive 2. 2x is greater than negative 1/2. Take note, if you're multiplying and or dividing by a positive number, the inequality symbol does not change. But if you multiply by a negative number, the inequality symbol reverses. Greater than becomes less than, and less than becomes greater than. Okay, let us locate these numbers on the number line. We have 2 9/2 and negative 1/2. The lowest of them all is negative 1/2, followed by 2 and then 9/2. Because if you will convert 9/2 to mixed number, that is 4.5. So x is greater than 2, so numbers to the right of 2. X less than 9/2, numbers to the left of 9/2. X greater than negative 1/2, numbers to the right of negative 1/2. And what is common to the three of them? Which part or which interval? This one only here. So numbers greater than 2 but less than 9/2. So the open interval from 2 to 9/2. Not including 2, not including 9/2. So we put their parenthesis on 2 and parenthesis with 9/2. Example number 6. Logarithm of 4x plus 1 to the base 2/3 is greater than or equal to the logarithm of 2x plus 5 to the base 2/3. Our base is still less than 1, so 4x plus 1 should be less than or equal to 2x plus 5. As what you can see here, our base is less than 1, so if it's greater than, you get the logarithm, we will have less than or equal to. So put 2x to the left, 1 to the right, you will have 4 minus 2x is less than or equal to 5 minus 1. 4x minus 2x is 2x, 5 minus 1 is 4. Divide both sides by 2, x is less than or equal to 2. 4x plus 1 should be greater than 0, so 4x should be greater than negative 1. Divide both sides by 4, we will have x is greater than negative 1/4. 2x plus 5 should also be greater than 0, so 2x is greater than negative 5. So x is greater than negative 5/2. Identify these numbers on the number line. The lowest is negative 5/2. Next is negative 1/4. And then the biggest is 2. Okay, x less than or equal to 2. So from 2 to the left. X greater than negative 1/4. So from negative 1/4 to the right, but negative 1/4 is not part of the solution, so hollow circle. And then x is greater than negative 5/2 is also to the right. So what is common to these three intervals? So this one here, this part here, only this interval. So all numbers greater than negative 1/4 but less than or equal to 2 can satisfy the given inequality. It should be solid circle here because 2 is part of the solution. So it should be a solid circle here. So we should have a bracket on 2. So negative 1/4 to 2. So all real numbers greater than negative 1/4 but less than or equal to 2. So it should be a bracket here instead of a parenthesis. So bracket at 2 because 2 is part of the solution. Okay, let us have some exercises here. Solve the following logarithmic inequalities. We have here 4. 1 and 2 have bases greater than 1, and 3 and 4 have bases less than 1, but greater than 0. So don't forget that if you're getting the base or the logarithm, and you are leaving what's inside, if the base is greater than 1, don't change the inequality symbol. But if the base is less than 1, you have to change the inequality symbol. Number 1, logarithm of 3x plus 9 to the base 3 is greater than or equal to the logarithm of x plus 13 to the base 3, and so on. Okay, pause the video if you have or if you need time to answer this one. If you're done, you can play the video. Let's answer number 1. So logarithm of 3x plus 9 is greater than or equal to the logarithm of x plus 13. So you will have x plus 9 or 3x plus 9 is greater than or equal to x plus 13. Put the x's together, the constants together. 3x minus x is 2x. 13 minus 9 is 4. Divide both sides by 2. X is greater than or equal to 2. And then 3x plus 9 should be greater than 0. Put 9 to the right. That will be negative 9. Divide both sides by 3. X is greater than negative 3. X plus 13 should also be greater than 0. So x is greater than negative 13. So we have to locate on the number line the numbers 2, negative 3, and negative 13. Of course, the lowest is negative 13, so it should be on the left. Okay, between them, between the two is negative 3, and then the biggest is 2. Okay, x is greater than or equal to 2 from 2 to the right. X greater than negative 3, so from negative 3 to the right. And x greater than negative 13 from negative 13 to the right. And what is common to them is on the right of 2. So all numbers from 2 to positive infinity can satisfy the given inequality. Second number, log of 2 minus x to the base 2 is less than log of 8 minus 2x to the base 2. So the base is greater than 0. So if it's less than, it's still less than. 2 minus x is less than 8 minus 2x. Put the x's together. You will have negative x plus 2x is less than 8 minus 2. Negative x plus 2x is x. 8 minus 2 is 6. So x is less than 6. And then 2 minus x should be greater than 0. So negative x should be greater than negative 2. Divide both sides by negative 1. X is less than positive 2. 8 minus 2x should be greater than 0. So negative 2x is greater than negative 8. Divide both sides by negative 2. You will have x is less than 4. So we have to locate the numbers 2, 4, and 6 on the number line. Lowest is 2. Next is 4. And then the biggest is 6. X less than 6, all numbers to the left of 6. X less than 2, all numbers to the right, to the left of 2. And x less than 4, all numbers to the left of 4. So what's common to them is on the right or on the left of 2. So all numbers less than 2 can satisfy the given inequality. So in interval notation, you write that as parenthesis negative infinity comma 2 parenthesis. All numbers or all real numbers less than 2. Number 3, log of x plus 8 to the base 1/3 greater than log of 6 minus x to the base 1/3, and 1/3 is less than 1, so instead of greater than, you put there less than, if you get the logarithm. So x plus 8 is less than 6 minus x, put negative x to the left and put 8 to the right. X plus x is 2x, 6 minus 8 is negative 2. Divide both sides by 2. X is less than negative 1. Of course, x plus 8 should be greater than 0. That is, x is greater than negative 8. And 6 minus x is greater than 0. You will have negative x is greater than negative 6. Divide both sides by negative 1. X is less than 6. So we have negative 1, negative 8, and 6. The lowest is negative 8, followed by negative 1, and then 6. X less than negative 1 is all numbers to the left of negative 1. X greater than negative 8, all numbers to the right of negative 8. And x less than 6, all numbers to the left of 6. So what's common to the three of them is this part here. So negative 8 to negative 1. So all numbers greater than negative 8 but less than negative 1 can satisfy the given inequality. Last number, exercise number 4. Here we should have 2x plus 4 is greater than or equal to 4x plus 6. Take note that here we have a less than. But here, if we get the logarithm, it's now greater than or equal because our base is less than 1. So we will have 2x minus 4x is greater than or equal to 6 minus 4. That will be negative 2x is greater than or equal to 2. Divide both sides by negative 2. X is less than or equal to negative 1. 2x plus 4 should be greater than 0. 2x should be greater than negative 4. Divide both sides by 2. X is greater than negative 2. 4x plus 6 greater than 0. 4x is greater than negative 6. X is greater than negative 6/4 or negative 3/2. The lowest is negative 2. Next to that is negative 3/2. And then the biggest is negative 1. So x less than or equal to negative 1, all numbers to the left of negative 1, including negative 1. X greater than negative 2, all numbers to the right of negative 2. And x greater than negative 3/2, all numbers to the right of negative 3/2. And what's common to the three of them is this part here, from numbers greater than negative 3/2 but less than or equal to negative 1. So we have there, parenthesis, negative 3/2, comma, negative 1 with a bracket. Okay, so all numbers greater than negative 3/2 but less than or equal to negative 1 can satisfy the given logarithmic inequality. So that's it for this video on solving logarithmic inequalities. Don't forget to hit the like button, write your comments and suggestions below. I'd be happy to read them. That's it for this video. Bye! Thank you for watching. Comment, like, and subscribe. Bye!